Completing the square for ax squared plus bx plus c equals 0. When there's an a coefficient in a quadratic equation, and if you look here, this is what I mean by an a coefficient. So you have ax squared plus bx plus c, then it adds a step to our completing the square strategy. And the goal after completing the square is to get our quadratic equation to look something like this. So similar to what we had before, only we're going to have this a value in front of the squared binomial. And so in order to get that a there, what that means is we're going to isolate the x terms, just like before in this equation. We're going to isolate the x terms, and then we're going to factor off the a and proceed to complete the square from there. And honestly, there's no better way to demonstrate this than with an example. So just like before, we're going to isolate those x terms. So 3x squared minus 12x, and I'm going to add 15 to each side to get the 15 away from the x terms. And I'm also going to leave that big empty space so I can have room to complete the square. So I have 15 on the right-hand side. However, before I get to completing the square, if I have this a value in the quadratic, then I have to factor that off first. So I'll divide off 3 from x squared, and then divide or factor off the 3 from the negative 12, which leaves me with negative 4x. Only it's putting these two terms in brackets, so I'm going to leave that big space for completing the square, because I have to complete the square right next to the x terms. So now what we're going to do is we're going to complete the square just like before here in the brackets. So we're going to use this value negative 4. So negative 4 divided by 2 gets us negative 2. And then we square negative 2, and we get 4. So we have to add 4, and then we have to take 4 away. Now here's where the trickier part comes, which is that you have to remember that there's this 3 in front of the brackets. And 3, if we were to multiply it back in, it would multiply every single term in the brackets, including those 2 terms that we just added and subtracted away. So we need to get this negative 4 at the end. So I'm going to rewrite this just to make it a little cleaner. So this is what we have right now. I'm going to have to remove this subtraction of 4 that's in the brackets. I have to remove it out of the brackets. I want to take it out so that I can combine it with the 15 on the other side. But if I want to take that out of the brackets, I have to multiply it by the 3 that's in front of the brackets. Because just like we saw up here, 3 is multiplying that value of negative 4. So I can totally remove it from the brackets, but I have to apply that multiplication of 3. So let's go ahead and do that. So I have 3x squared minus 4x plus 4. And then negative 4 times 3 is minus 12. So I'm pulling that negative 4 out of the brackets, and to do that I multiply it by the 3, which is in front of the brackets, and now I'm left with negative 12 there away from the brackets on the right hand side. And we can see that here is our perfect square. This is that perfect square we wanted, and it's multiplied by 3, but that's okay. We can still rewrite that perfect square as x minus 2 squared, again minus because of that negative in the x coefficient. So I have 3 times x minus 2 squared, and then I'll add 12 to each side, and then I have equals 27 on the right hand side. So now I have 3x minus 2 squared equals 27. And now I can solve this equation just like we were solving quadratic equations with the square root principle before. So we divide each side by 3, and I get x minus 2 squared equals 9. And then I use the square root principle to say x minus 2 is equal to plus or minus the square root of 9, I have to continue my work over here, x minus 2 is equal to plus or minus 3. So that means that x equals 2 plus or minus 3, or x equals 2 plus 3 would be 5, or 2 minus 3 would be negative 1. So those are my two solutions to that quadratic equation. Another example. So we are going to begin by isolating the x terms, so subtracting 8 from each side, and then factoring off those two x terms, factoring that a value off. So 5x squared plus 20 divided by 5 is 4 is equal to negative 8. Just by random luck, we keep getting 4, so we should be able to expect what this one's going to do. So 4 divided by 2 is 2, and then square that value, and we get 4 again. So we have to add 4 and then take away 4. And when I take this 4 out of the brackets, I have to multiply it by 5. So that would be 5 times x squared plus 4x plus 4. And then I take that negative 4 out of the brackets, multiplying it by positive 5, and get negative 20 equals negative 8. And I'm going to ask for that to be on the right-hand side. So now I have 5 times, and completing the square leaves me with a square binomial here, x plus 2 squared, is equal to 20 minus 8 is 12. And now I'm ready to solve this quadratic equation, just like I was doing before using the square root principle. So I'm going to divide each side by 5 and get x plus 2 squared is equal to 12 over 5. And then use the square root principle to say that x plus 2 is equal to plus or minus the square root of 12 over 5. And that means that x is equal to 2 plus or minus the square root of 12 over 5. Now the square root of 12 over 5 can be simplified a bit, so I'm not quite at my final answer just yet. And I'm going to work over here on the right, where I have some room to do that. So x is equal to 2 plus or minus, well, so we have two things. One, we have actually, so I'm going to go 12, square root of 12 over the square root of 5. The square root of 12 can be simplified, and also we don't want a irrational denominator. So I have to rationalize this denominator as well. So let's do this in a couple of steps. So first I'm going to write square root of 12 as 2 root 3. And then I have over the square root of 5. And then I'm going to rationalize my denominator by multiplying the top and bottom by the square root of 5. So that would leave me, and I only have to do this on the second fraction because I'm multiplying by 1. So I can multiply any number by 1 without changing it. So I don't have to multiply the 2 by root 5 over root 5 as well, because doing that wouldn't accomplish anything. It would just be multiplying another number by 1. So I only have to multiply this term after the plus or minus symbols by root 5 over root 5. And that would leave me with 2 plus or minus 2. And then the square root of 3 times 5 is 15 over, and then the square root of 5 times the square root of 5 is 5. So there is my simplified best answer for this problem. Next up, I want to show you an example with a fraction. So the method is always the same. It's just that what our math looks like is going to be a little bit different, but the method's the same. So I isolate this, the x terms, and then I factor. So when I factor off a half, think about dividing things by a half. And as you'll remember, dividing by a half is the same as multiplying by 2, because you can flip. For division of a fraction, you can flip and multiply. So it's like multiplying by 2 over 1. So when you factor off a half from negative 3x, it's like multiplying negative 3 by 2, which leaves you with 6x. And then leave some space, equals minus 5. Now if you need to convince yourself of that, multiply the 1/2 back in, and you'll get 1/2 x, and then 1/2 times negative 6 is negative 3x. So if you need to convince yourself that dividing or factoring off that half multiplies the same as multiplying by 2, there's your little proof of that. But now that we've got that 1/2 factored off, we're ready to proceed as before. So we take our negative 6 and we divide it by 2 and we get negative 3. And then we square it and we get 9. So we're going to add 9 and then take 9 away. And that's our first step for completing the square. Now I'm going to write it out because it's going to get, you just have to be careful with your math here. So when we pull this negative 9 out of the brackets, we are multiplying it by 1/2 because 1/2 is the value outside of the brackets. So we have 1/2 times, and what's left behind is that perfect square. So that would be x minus 3 squared. And then we pull the negative 9 out and multiply it by half, which means we have negative 9 halves now outside the brackets. And we're going to add this to each side of the equation to get it over to the other side. So now I have 1/2 x minus 3 squared equals negative 5, which in order to combine it with 9 over 2, I'm going to write that as negative 10 over 2 plus 9 over 2. So we have a fractional answer, but that's okay. It's just what it is, and it's what the math leads us to. So I have 1/2 times x minus 3 squared equals negative 1/2. I have negative 10 halves plus 9 halves. And now to solve this, we'll do it just as before. I want to get rid of that 1/2, so I'm going to multiply each side by 2. So I get x minus 3 squared equals negative 1. And then use the square root principle, and I get x minus 3 is equal to plus or minus the square root of negative 1. And now here, I recognize that I cannot have the square root of negative 1, which means that there is no solution. And so in this problem, my answer is actually no solution. However, when you're solving these problems, we still expect you to attempt to solve it using the, if you're told to solve it using the completing the square method, we still expect to see you attempt to solve it using the completing square method and get to the point where you have to reject the answer because of this square root of a negative. So you still have to go through the work even if the answer results in no solution. And we'll do one last example just to wrap it up. So to start with, we're always isolating the x terms. So we add 2 to each side. We get 4 on the right hand side. And now we factor off the 3. And here we're going to get something interesting. We're going to get x squared plus, well, 2 divided by 3 is a fraction of 2/3. 2/3 x. So again, fractions can happen. Because we had to take the 3 off of each term, take that 3 off, well, 2/3 divided by 3 does not result in a nice, or sorry, 2 divided by 3 does not result in a nice number. It results in 2/3. And now we're going to have to use this value of 2/3 to complete the square. So we have 2/3 divided by 2. 2/3 divided by 2 is 2 over 6, which we can simplify as 1/3. So 1/3 is half of 2/3, and that makes sense. And then we're going to square it, and we get 1/9. So 1/9 is what we have to add and then take away. And when we take 1/9 out of the brackets, negative 1/9, so that we can have the perfect square all together by itself, we'll have to multiply it by 3. So I have 3 times x squared plus 2/3 x plus 1/9 minus 3 times 1/9 is 3/9, which we'll be able to simplify. So that's 3 times, and here's our perfect square. And if you're wondering, well, what is the, it's going to be x plus or minus something. It's going to be plus because it's a positive x coefficient. And it's going to be plus the square root of 1/9, which is 1/3. So that's my completed square there. And minus, I'm going to simplify that fraction. Minus 3/9 is the same as minus 1/3 equals 4. And now we just begin solving as we have been. 3x plus 1/3 squared plus 1/3 on each side. Well, 4 is actually, as thirds, is 12/3 times 3/3 if you want to, plus 1/3. So I have 3 times x plus 1/3 squared equals 13/3. And now I have to divide each side by 3. Divide by 3. So I get x plus 1/3 squared equals 13/3 over 3 is the same as 13/9. If you need to take a step to do that, try, I'll do this up here, 13/3 divided by 1/3 is the same as 13/3 times 1/3. Because we have something divided by 3 is the same as something times 1/3. So that's 13/9. And now we can take the square root of each side, or in other words, apply that square root property. So I have x plus 1/3 is equal to the positive or negative square root of 13/9. And to write this in simplest terms, I'll recognize that the denominator is a perfect square. So this is plus or minus the square root of 13 over the square root of 9, which is 3. And then add 3, or sorry, I'm not going to add 3. I'm going to subtract 1/3 from each side to isolate x. So that would be negative 1/3 plus or minus square root of 13/3. And that's an acceptable solution, or because these two fractions have the same denominator, this is -1 plus or minus the square root of 13/3.